Hi everyone, my name is Alannah Oleson and I'm here presenting on behalf of my co-authors Meron Solomon, Christopher Perdriau, and Amy Coe, and today I'm talking about teaching inclusive design skills with the CIDER assumption elicitation technique. So to start off, I'd argue that inclusively designed technology isn't just a matter of convenience and comfort. It's actually an issue of just and equitable access to information and resources, given how much we use and rely on technology nowadays. We know from prior work that technology often fails users from marginalized groups more often, such as those who have different abilities, cultures, classes, races, ethnicities, or genders from those that are systemically privileged in technological contexts. One of the most prevalent vectors for bias in technology design is inaccurate assumptions made about users. As it turns out, designers embed their biases into the technology they create. They can't avoid it. The most they can do is recognize when it's happening and try to account for it. On top of that, assumptions are a necessary part of design work. One designer or design team can't know everything about the world or how their creation will be used, so they have to make assumptions to fill in some of those gaps. The problem arises, though, when those assumptions require users to have particular skills, capabilities, identities, knowledge, or access to resources. When users don't fit those assumptions, the technology often fails to work well for them. So why focus on teaching computing students inclusive design? In most computing curricula, there's very little design training given to students, much less inclusive design training. However, computing professionals like developers and software engineers are often in charge of technological design decisions. Because education impacts practice, emphasizing inclusive design principles from the very beginning of whatever design training these students get will hopefully encourage them to create more inclusive technology in the future. So for this study, we began with this goal. Let's teach computing students to check their assumptions so they can design more inclusively. And to do that, we created the CIDER technique, which stands for critique, imagine, design, expand, and repeat. The goal of this technique is to help computing students think beyond average users and learn to recognize and respond to design biases in technological user interfaces. The technique is designed to target some common learning difficulties that computing students can face when they try to learn inclusive design. And if you're interested more in the theoretical grounding of the technique, there's a bunch more about that in the paper, which you can find at that link in the bottom corner, cider.design/paper. At a basic level, each complete CIDER activity consists of one setup task performed by the instructor and 5 stages, which students participate in. Now, in the interest of time, I'm not going to dig deep into each of these stages. There is a full example activity in the paper that walks you through it, but you should know that each of these 5 stages, for the CID, the critique, imagine, and design stages, they give students scaffolded practice critiquing exclusionary assumptions in everyday technologies. The peer feedback that students get in the E, expand stage, helps students gain new perspectives that maybe they hadn't thought about before. And the repetition of those first 3 stages in R, the repeat stage, helps students engage with the perspective they haven't previously considered, expanding their knowledge base for what design bias looks like and how it manifests by at least one example. So to evaluate the efficacy of the CIDER technique, we conducted a mixed methods case study in a post-secondary introductory design course with 40 computing students over 11 weeks of instruction. Students participated in 6 different CIDER-based activities, as well as filling out some weekly self-efficacy surveys, and we also followed up with some of them after the course to see how the activities influenced their design approaches, if at all. So what we found was that many of these students gained self-efficacy as inclusive designers, with some attributing their newfound confidence to the CIDER activities themselves. Some said that these activities provided aha moments, revealing design bias in everyday objects and helping them see how a design that works for one person might exclude another. Students in the course also identified several different kinds of biased assumptions that were embedded in designs, including those about capabilities, context, prior knowledge, and access to resources. And in the follow-up interviews about a month after the course, a handful of students told us that they had used knowledge they'd gained from the CIDER activities to reason about inclusion in their design internships or their other projects, implying at least some lasting impact of CIDER on their design approaches. So I'll go ahead and wrap up by saying there are several more cool insights in the paper. Highly encourage you to check it out. We have some discussion about how CIDER could be adapted for team-based work, as many design classes are team-based or project-based. We have some guidance for choosing artifacts to use in CIDER activities and kind of targeting maybe different kinds of inclusion that you'd like students to focus on. And we do have some general advice for educators who are interested in using CIDER in their courses. Our next steps with this technique is we are currently running a study to evaluate the efficacy of CIDER in several different learning contexts, several different courses with different focuses and all that. We are starting to see some interesting results there, which I look forward to sharing in the future. Thank you so much.